Hey, John here. Let's talk about symbols that have multiple units. Let's start with what the heck a unit is. Okay, so let's say you have a symbol that's fairly complex, like a huge number of pins. Most obvious example I can think of is an FPGA, like a Spartan 6. I've worked with these in the past. So this is a 484 pin. Here's one with 676 pins. There's one with 900 pins each. I have never worked with them that are quite that big. Let's look at something a little bit more reasonable, like 200 pins, or even maybe a 144. Here you go. Here's one with 144 pins. This is relatively small by FPGA standards. See this arrow over here? Right up here, this is the library, and this arrow up here says, show me the parts. Some of the symbols that are inside the Xilinx Spartan 6 library. Down here, for the 144, this is the 144 pin FPGA. The arrow here says, show me the units with which this particular symbol is comprised. So I have a unit A, and a unit B, and a unit C, and a unit D. And you can see over here in this little side viewer thingy, that they're quite different. C and D are completely different things, and A and B are very similar, but if you switch back and forth, you see the number of pins here are different and the number of pins up there are different. So these are four unique and individual separate subsections of what it means to be one single symbol. So let's put unit A down here. So what we're really doing here now, let's say I want to design a circuit with this, and here's unit B. Here is unit C, and here is unit D. These are the four units that comprise one single symbol. Obviously, I might want a bigger sheet, or I might want to put these on separate sheets, okay? Clearly, having this in multiple units like this, if I can, and I can, with KiCad, put the unit B over here. See where it says U question mark B, and then this will be U question mark. There's unit D. These are all of this same symbol. Because they're physically separate units, I can put these on separate sheets if I feel like it, or I can put them all in the same like I did right now. So one of the reasons we want multiple units is so that I can put these on multiple sheets. The other reason to do it is even if it's on one sheet, what am I going to have, one giant square thing on here? That would be a nightmare to deal with. This unit down here strictly deals with power. So if I had a power supply sheet in my design, I just put this over on the power supply sheet and connect it up over there. It doesn't have to be, over here and cluttering up my page of logic. This here is this is obviously a JTAG interface, and this is the kind of programming interface that the FPGA uses to download its code from a serial EEPROM, if you're familiar with how these things work. And these guys up here, these are all the I/O pins. Basically, an FPGA is just a giant ton of GPIO, and that's about it, and then it's filled with gates inside, and you can have them do various things. They're kind of fun to play around with and program with if you ever learn how to do this. It can be a lot of fun. Anyway, so this is what a multi-unit, one of the reasons that you want a multi-unit part. Deal with dividing these pins up into sections so they're more manageable, including the allowance of getting it onto multiple sheets if you want. All right, so when I put this thing together here, I put down the A, B, C, and D parts all at once, and because I knew that's what I wanted to do here. If I wanted to put them across multiple sheets, I might put the A down, and then I might put the B down later on, and so on when I'm on the other sheet. That's all fine and dandy. The important thing, though, is to remember to put all of the units down. If I forget to put the D unit down, for example, the design rule check is not going to verify that I forgot to hook up these pins because the unit's not in my schematic at all. There's no pins there for it to notice are not connected. So number one, make sure you put all the units down if you're going to work with these things. Otherwise, your DRC won't work. So this is one kind of multi-unit device where each unit is unique and has different roles and different numbers of pins and even different shapes and sizes. So I'm going to Control Z and get that guy out of there. Here's another kind of multi-unit symbol. Let's look at, first of all, let's look at it physically. Let's say you want to use one of these ganged potentiometers. This is a 6-pin device, much simpler than the FPGA. It's just, obviously, physically, you can see what this thing is doing. It has 2 separate pots here. Or here's one that's actually got a 6-pin footprint that's PC board mounted, which is a little easier for us to think about in terms of what's going to happen with our design. So the same 6 pins here, it's the 2 gangs are obviously right there and there. Okay, so when we do that, let's go look for a potentiometer. All right, here we go. Here is a library cleverly called device that has devices in it. Here is a dual ganged pot with 6 pins. And you'll notice right next to it, there's a little arrow. So this is a multi-unit version of the same design. There's one where they're all one single physical symbol. And here's one where you have unit A and unit B completely independent of each other. Let's put them both down here, unit B. Now, this might be more useful than the one single multi-gang drawing, because if, again, for example, let's say these are the volume controls for a fancy, your super exciting, super duper amplifier you're building. And let's say you have a 1-channel schematic drawing that fits on a sheet, and it has a volume control knob in there. Well, you can use the same sheet on 2 different sheet symbols like we did with the mic preamp project, and you can put one of these pots on one sheet and one on a separate sheet. That would be very handy, especially if they're buried in the middle of the design and it becomes inconvenient to route some signals out of the sheet into the parent sheet, and in order to go to one of the 2 ganged pots in the single unit symbol design. This is pretty handy. What else is interesting about this? Okay, well, where the FPGA had 4 completely separate and unique units, this one has 2 separate and identical units. These are defined differently. All right. Now, this particular symbol in KiCad is designed such that it allows the annotation system to arbitrarily swap these 2 A and B units. Okay? The FPGA is not designed that way. It would be completely inappropriate to swap, as you recall, the D unit that was over here was like the power interface with the A unit that was up here, which was a bunch of I/O pins. They're physically not the same. The pins are in different places and completely different roles. They have nothing to do with each other, other than the fact that they're on the same physical device. These 2, on the other hand, are exactly the same. They're drawn the same. And if I change this A to a B, which I can do by double-clicking, opening this up, and now that I'm dealing with a multi-unit part, you see this A over here? I can change it to a B. Watch what happens to the schematic when I do this. It's an A right now. There's the A, and got 1, 2, 3. If I go to a B, it now, when I hit OK, it's now a B, and it goes to 4, 5, 6. All right, now they're both B's, which doesn't really make a lot of sense. If I did this and maintained this would have to be 2 separate pots with the A unit not connected and not used here, and the A unit here also not connected and not used. So if you do this, you got to make sure it makes sense. If you're going to swap that one, you're going to have to come over here and swap this one if you want both of these really to be the 2 separate units on a same physical device. Now, there's a kind of a variation of these 2 kinds of parts that is the almost identical. If you use an OpAmp like an NE5532, we see unit A, unit B, and the only thing that's different are the pin numbers, just like the multi-unit pot. And then you got a unit C, which are the power pins for the chip. Okay, so let's put these down here and have a look, see at what's going on there. Maybe I'll make a mic preamp with op-amps instead of a transistor. It's a little bit easier, except for I have to deal with the power supply needs. Okay, so now I've got an A amp and a B amp, and this C unit is the power. All right, now when we were playing with this, you'll also notice there's a variation in the DigiKey library, which is a similar multi-unit part, but this one only has 2 units. So let's look at that one. That's what we got here. So this, as you can see, is a mixture of this previous one that's in the KiCad library. So the KiCad library puts the power here, in one unit, and then it has an A and a B OpAmp over here. The DigiKey one has an A and a B unit with the power on the units as well. So what's that all about? It only has 2 power pins. So there's an A and here's a B. And pin 8 is on both of these 2 units. So again, this is where overview before we dive in and design one of these. We need to see where we're going, right? So in this particular variation, it has 2 pin 8s. So when you do this in KiCad, you have to have symbolically or directly physically, both of these pin 8s have to go to the same net. And both of these pin 4s have to go to the same net. Otherwise, it's a design rule error, okay? There's benefits to this. Like the potentiometer, if I switch the A and the B around, it's fine. And I can indiscriminately do that as far as my schematic goes. I can swap all of the units of this part with any other unit. There's just 2, so it's just swapping. But if they had a 4-channel OpAmp that was designed this way, all 4 could be swapped around arbitrarily. If you do that this way up here, this is more like the FPGA, you know. It turns out these 2 can be swapped indiscriminately, but you cannot swap an A with a C or a B with a C. No. All right? So this one here does not allow arbitrary indiscriminate reassignment. The potentiometer can and does, and this DigiKey version of this design can and does as well allow us to do that kind of swapping around. Why? Couple reasons. One, every pin in the A unit has a corresponding pin in the B unit with the same row, in the same label and everything. If the same number appears in both of these, like I said before, these 2 have to physically be connected or logically connected to the same net in your schematic design. You can't hook pin 8 here to like +5 and this pin 8 to +12, because then what does that really mean? You're hooking 12 volts to 5 volts, and it just doesn't make any sense. Unfortunately, KiCad requires you that both of these 8s are in fact connected. You can't hook this 4 and this 8 and this 4 up and then make these 2 no connects with this guy over here, right? I cannot do this and then hook this to plus and minus 12 or something like that. That would be, convenient, but that's not how KiCad wants you to do this. So I'm going to undo that. All right. This one up here, what are the benefits of this design? It seems, why bother doing it this way? Well, sometimes it's nice to just put all the power in one section of your schematic. If you had 9 of these in one schematic, you could put all the 9 sets of power pins off to the side or even on its own sheet, while all of the 18 op-amps in that scenario could be strewn all over your schematic, even on multiple pages or whatever you want. And this is actually a very common way of drawing op-amps in schematics. Down here, this is not uncommon either, to show the power on the op-amp. So you can decide what works best for you. Either, show the power on all of them or on none of them with it off to the side. All right, so while we're talking about the ability to swap the A's and the B's around, we need to be somewhat careful about being too cavalier about doing so. If you've already routed your PC board and you've got pins, 1, 2, and 3 hooked up to, some other parts of your circuit, and maybe the other one's over here hooked to some other part of the circuit, and you decide you're going to re-annotate this in such a way that the letters change, or even, allow you to put gate A of, U1 and swap this from U1 gate B to U5 gate B, these pins are going to change and you're going to have to reroute your board and stuff like that. So indiscriminately re-annotating your board for the part reference numbers or changing the letters can cause you a problem, right? So you need to be aware of exactly when and to what extent you want to redo the annotation in your designs. And we'll look more at that as we go. Now, as you can see, the annotation process now is more important than it has been in the past. Just changing the number of a part reference is not really a big deal. For all intents and purposes, all that really does is change the silkscreen layer on your PC board. Big deal. On the other hand, if this is U101A and U101B, and you change this to 102B and leave this one at 101A, you've now rerouted, where these wires are going to go in your schematic, by splitting these into different parts than where they were before. That is a significant change. And yes, you can do that in KiCad, but you need to keep your wits about you so that you don't do it when you don't want to. So keeping these things in groups is kind of a theme now. And if you look at the annotation system, see where it says reset, but keep order of multi-unit parts? This starts coming into play here. To see how all this stuff comes together and how it works, let's throw down some designs and see what happens. So what do we want to do first? Let's start really simple. We've got any 5532s up here. We actually have 4 OpAmps, okay? Now these symbols are completely different. So KiCad is smart enough to know not to swap this A with this A up here. I mean, theory you could, right? These are both the same chip. This one's a P and this is not, but I can easily go change that and we can find out just how smart or dumb KiCad really is. If these are both 5532s, now you'll notice I edited just this one and they both got changed, right? That's because KiCad knows these go together. Okay, the same thing would happen if I start messing with these to some extent. If you assign a footprint to this one, then the other units in the same symbol would have to go along with it. Again, you got to keep these things all in agreement. So let's see what's going on here. First of all, let's just do the automatic annotation, reset everything, and start from scratch. What's it going to do? Can't undo it. That's the warning we get. Okay, so what do I got? 101A, 101B, 101C. That makes sense. What's this guy? 102A and 102B. That makes sense too. Let's see what also interesting things happen here. Let's move this way up here, all right? And just re-annotate it again. Well, first of all, let's show, as you should already know, if we don't do anything, we re-annotate it 4 times, blah, blah, blah. You could do this as many times as you want, and because it's annotating left to right, top to bottom in the order that we've chosen, these never change. Once I haven't changed the schematic or redrawn anything, so why would they change, right? But let's move this up here and watch what happens. If I do a reset and re-annotate, let's move these closer together so it's easier to see what's going on. Okay, so what do we got up here? I moved the B up here and the A down there. This is U102B and 101B and A and C over there. All right, let's do the full reset and re-annotate now. Let's see what happens here. Okay, now what happened? Well, it redid the B. It went from 102 to 101. Why? Because this is above all the other ones, right? Left to right, top down. So this became 101. It was a B, and it stayed a B. We'll talk more about that in a minute. And KiCad knows that this symbol is in a group of 2 guys that have to stay together. So by changing this to a 101, the other symbols in this same, or the other units rather, I should say, in the same symbol have to go with it. All right, so both of these became 101s. And the next available number then becomes 102. So this guy went from 102 A, B, and C to 102 A, B, and C. Again, that makes sense because these all kind of go together. All right, now what happens if this gets more interesting, right? So now I got 2 different symbols. The point of this part of it is that KiCad's smart enough to know not to intermix things that have completely different symbols from the library. So I'm going to delete that. We've proven that. What does it do if you mix a bunch of parts that are from the same symbol? Okay, here's a B, here's another C. Let's put just this many down here. So this is actually obviously 2 parts, 2 dual channel OpAmps. Okay, let's do a full reset and re-annotate. And as we would have expected, these become 101s, these become 102s. what happens if I change this A to a B? Well, I have two 102Bs right now. That doesn't make any sense, right? Let's re-annotate and see what happens. Reset existing annotations. Now I got 101 A, B, and C, 102 B, and it knew that I can't have two B's in the same part, so it says, he must have a third one, so I'm going to make this 103B. Here's the power for 102. I'll move that up here. And I no longer have, I'm not even looking at 102A, and I don't have a 103A, and I don't have a 103C either. If we do a design rule check right now, it'll tell me that everything's disconnected. Okay, not connected, not connected, not connected. All right. But if you go through all these, you'll find out in nowhere does it say that U103C is missing. Why? Because the design rule check only checks the units that are on your page. So if we look at the, what we got pins 7, 6, and 5 of 103B, and you can see the 103 right here. Oh, I double-clicked on it, and it disappeared. Oops. Don't do that. Okay, so what do we got here? 102, 102, 103. So pin 5 input is unconnected, and we got a pin 5. We got a pin 6. We got a pin 7 of U103. It says pin 4 of U102 and pin 8 of 102 are unconnected. Okay, but nowhere did it say pins 4 and 8 of U103 are not connected. If you go through this, I'm looking at the 103s down here. We scroll slowly through this, 101s and so on. We don't see anything about that in here, all right? So you have to be careful, is my point. If you're playing around with these things indiscriminately, you're going to screw them up. Okay, so now you've got sort of a bead on what's happening with the automatic annotation. If we, now let's look at something else. Let's make this one an A. Let's put it back to normal. Move it back to an A. Okay. Now, once I've done this, if I do a full annotation, it's going to know, all right, now I know I got an A and a B and an A and a B, and these all can get collapsed down to two simple parts, a 101 and a 102. We've already played this game with the other parts. Well, I brought it up here, the other parts being the DigiKey ones. Let me clear the markers, get that noise out. Remember when we did this with the DigiKey part, it kept this A and the B together and the C together, and it did this in that scenario because these are different symbol than the symbol that represents these three guys. So if I do a full reset and re-annotate right now, it's going to be allowed to do whatever it wants. These are all from the same symbol. So look, now I got a 101A, and the 101B now is no longer down here. It moved me up here. In the 101C, got moved up to here. So 102A is this guy here, right? It already used a 101A, and when it got another A, it said, oh, I got to use a different reference. So it said, I'll use 102, and as it goes along, it runs into this and says, oh, I got a C. Well, I'll make that 101 to go with this guy. I got a B. Okay, fine. It can go with this guy up here. Use the lowest number first kind of logic, right? And then when it sees a C and a B down here, it goes, well, I haven't yet used the 102C and 102B, so we end up with that. Now, if you do this, this is okay, but if you've already routed your board, what you've now done is you've moved traces from one physical device completely to another one. That can be incredibly confusing. So let's undo this and re-annotate it back the way it was and show you if you end up doing this in your schematic and you decide to re-annotate your schematic, what do you want to do? Well, if this does sort of happen, that's what this other option's for down here. Don't reset everything. For the most part, you never really want to use this anyway. You can, I suppose, in the very first, draft, early draft, before you've done any PC board routing or anything at all, especially if you don't have multi-unit parts, this is kind of useful. But this really means kind of the same thing. I don't like the way this is phrased. I've seen there's a newer version of KiCad coming out with it. I think it's phrased a little bit more clearly. What this really means is don't do what just happened, right? It says, look, if I say keep the order, what I'm really doing is saying keep the groupings. All right, I got 102A, 102B, and 102C over here right now. And I got 101A, B, and C. These three are one physical device, and these three down here are one physical device. So if I choose this one instead of the middle one, what will happen is the guy on top will become 101A because he's higher. All right, but because it was grouped with this guy down here and this guy over here, they all became 101. So this stays the same physical package, physical device, moved as a whole. I can re-annotate the number, but I'm not allowed to swap the A's and B's between different physical devices. So 101, A, B, and C all went as a group to 102, A, B, and C. That's what really happened here, all right? So this is the essence of these options in here when playing around with multiple unit devices. Now, obviously, keep existing is a very handy thing to do. If you do these by hand, which I usually do, by the way, especially when I go with multiple units like this, I'll leave it on keep existing and only deal with, oh, I added some resistors, give them some part references, or I can do those by hand as well. So when it comes to multi-unit parts, one of the most important things to deal with is this annotation problem. An agreement. You can't put a quad flat package on an A and in the same device give it a dip package or something like that. Clearly, these all have to agree. There's plenty of design rule errors that you'll see if you play around with that. But again, the design rules cannot fix this problem. If I delete one, it will not check what is not there. So you have to be very careful that you put all of the lettered units into your design if you're counting on the design rule checks. So hopefully this gets you a little bit acquainted with the concepts of multi-unit symbols. Next time we'll talk about how to create them and how you can get a little bit of control over how and when KiCad is allowed to change the letters of the units during an automatic re-annotation process. Let me know what you think in the comments below. If I could have done better, definitely let me know. Thanks for watching. Bye.